Down to perpendicular lines here. Okay. So you may recall that perpendicular lines have opposite reciprocal slopes, right? But that's not the formal definition that the book is going to give you. Right? The book's going to give you this: the product that says two non-vertical lines are perpendicular. There's a little cool symbol for perpendicular. You don't use this upside down T, right? Perpendicular. If and only if their products of their slope is -1. That's interesting. Okay, so I want to make sure you guys know the difference between the word reciprocal and the word opposite. So I'm going to give you a number right now, a little quiz, okay? I'm going to give you a number. You shout out the opposite of 1/7. Okay, I had two people that kind of said something. Let's try this again. Shout out the opposite of 1/7. Yeah, -1/7. Good. What is the reciprocal of 1/2? 2. What's the reciprocal of 2? 1/2. Oh, good. So reciprocal means fraction involved, right? But opposite means sign. Okay, so when you put those two things together, take the opposite and reciprocal, you end up with two perpendicular lines, okay? So I have two lines down here that I'm going to show you are perpendicular, right? I noticed that the slope of this is a positive 1/3. The reciprocal of 1/3 is 3. And, of course, the opposite of 3 is -3. So I have two of these. I'll throw a graph right in here. I need to dim the right node now. So I'll put this one in. That's my red one. Put that one in. There's my blue one. Okay, so these are definitely opposite reciprocal slopes, okay? And if I do a little math over here, right, I can see that according to the definition, the product of their slopes must be -1. So if I take 1/3, in fact, I don't want to use this one. I want to use purple. So 1/3, if I multiply that by -3, notice I do get an answer of -1. And that will happen every time for you if they are indeed perpendicular. Okay, bring up your calculator. Okay, what we're going to do is I'm going to show you another little trick in your calculator. So turn it on. Go to y equals, go to the first y equals bar. We're going to punch in that first equation, 1/3 x plus 3. So I need you to go parentheses 1 divided by 3, parentheses x plus 3. Everybody good? Okay, next I want you to go down a line. Type in negative, use the negative button, not the subtraction button, the negative button. -3x plus 2. And then, of course, we want to make the distinction between the two lines. So let's go over here and make that one a little thicker by pushing enter. Now, let's hit graph together, and you should see this.
It doesn't look that good.
Yeah, I'm glad that you brought that up, right? Is there something that's bothering you just a little bit about this? It doesn't look, those don't look perpendicular, do they?
No.
Anybody have any guesses as to why? Yeah, Olivia, what do you think? That's right. The little notches aren't spaced evenly on the x-axis versus the y-axis. You want to know how to fix that? Check this out. Go to zoom. See how option number 5 says square? Here's the cool thing. Just push the button 5. That evenly spaces your x and y grid. Okay? And now all of a sudden they sure do look perpendicular. Would you agree with that? Yeah, very cool, right? Okay. Awesome. Go ahead and put that away. Okay, with your partner, I'd like you to try this problem right here. You do not have to write it down. Find the equation of a line in slope-intercept form passing through 1, -2, and perpendicular to that. And then graph the line using your ruler on your graph paper, and then check it with your calculator.
Whoa.
An approach that they used. Adrian, give me the approach that you took.
Well, first I put the equation into standard form, or not standard, slope-intercept.
So you did x plus 3y equals 6. So 3y equals -x plus 6. So y equals -1/3 x plus 2. Is that what you did first?
Yeah.
So what's the slope of this line? -1/3. What's the slope of the line perpendicular to that? 3. Do you notice how I wrote that down? See how I wrote that down right in the page? Okay, so I figure out the slope of line, then the slope that I want perpendicular would be that. So then, how do you figure out the line that contains that point? What do you use?
Then you can use
point slope form, which is y minus y1 equals m times x minus x1. So that'd be y minus, or y plus 2 equals the slope, which is 3 times x minus 1. Is that what you did?
Yes.
So that means that y plus 2 is equal to 3x minus 3. So y must be 3x minus 5. That's a great approach. Now, how do you check to see if those lines are indeed perpendicular? What can you do, Daniel?
If 3 times negative 1/3 equals -1.
There we go. 3 times negative 1/3. Does that equal -1? Check. Those lines must be perpendicular. Now, how can you check to verify it goes through that point? 1, -2. You can graph it, right? You can easily graph it. So all these are, what were the two equations?
Y equals -1/3 x plus 2.
That's not good. Like that.
And y equals 3x minus 5.
Bam. Okay, so hopefully you got this to show up on your graphing calculator as well. If we zoom in, we can see that the point 1, -2 is clearly on the graph, so we must have done it correctly. You guys feeling pretty good about that?
Yes.
All right, great. Let's move on to circles.
Circle.
Okay, let's go on to circles here. Okay. So for circles, I kind of messed up the definition. I tried to fix it, but it's not all the way that perfect. So for circles, right, definition is a set of all points in the plane, xy plane, that are equidistant r from a fixed point h, comma, k. It's not important that you really have that down. Okay, you can just download the notes later. What's important is that you understand what all the pieces are. Okay? So the real important part of this is the idea of a circle whose equation is in standard form. Okay? And the standard form for a circle is the stuff that's highlighted here. And that's the important part. You've got x minus h, quantity all squared, plus y minus k all squared equals r squared. Now, the two really important pieces are the center, okay? The center is at h comma k. And do you notice that the center, their sign value is opposite? Do you see that? How this is negative h here, and then it becomes h? This is negative k here, and it becomes k. You notice that? That's important. And then the radius, of course, is just r, right? R is the radius, right? Now, what's so nice about in standard form, Ethan, pay attention, dude. What's so nice about standard form is that you can look at an equation and know exactly where it is in the xy plane. Okay, but before we get to that, I have a little thing set up here I'd like you to take a look at. It's giving you some room here. So what I've done, right down here, is I have a graph, okay? And over here in the highlighted part that I'm pointing now is I have the generic standard form for a circle. You see that? And then I have the h, and I have a slider for the h. I have the k, and I have a slider for the k, and I have an r. So I have all the pieces that I need, the h, the k, and the r, and I have all of those individualized. Now, watch, do you notice that the h is tied to the x value? Do you notice that in the binomial? So check it out. When I move the h left and right, or the value, what happens to the graph? So what is the h's role in this whole equation? The x tells you where it is on the x-axis, right? Now, what do you think the k does? Whoa, super trippy, right? Okay, so notice those are independent of each other. And, of course, what will the r do? Whoop. Now, check this out. Question for you. Why does my r value, when I'm negative, still produce a circle? That's right. A negative number squared gives you a positive. So, look, I can move my thing left and right. I can move my circle up and down. And I can make it bigger or smaller depending on r. That's the cool part of standard form. You guys see how that works now? Okay, great. So, last idea for the day. I'd like us to graph this together. Right. Do you have this thing written down? Okay, you should be upset. I'm upset. Yeah, what's wrong with this thing?
Not standard form.
Yeah, where's the center?
No one knows.
No one knows. What's the radius? I don't know that either. Okay, so how do we get ourselves to take this thing and put it into standard form? Subtract 12. That's a good start, but there's more that we have to do. After that, what would we do next? Divide by 2?
Take square root.
Take the square root. Are you just throwing things out there?
Yeah.
Okay. Do you remember this idea of something called CTS?
Oh.
What was that?
No more chief.
What was that? What does that mean, CTS? Complete square. Now, which one of those variables is squared? X and y. So which one do you complete the square on?
Oh.
Yes, both of them. Watch the procedure. It's actually pretty slick. Here we go. X squared plus 4x plus the magic number for that plus y squared minus 6y plus the magic number for that equals, like Daniel said, negative 12. Move that over to the other side.
What's the magic number?
But you have to add both those magic numbers in, don't you?
Yeah, I just looked complicated.
Now, please do me a favor. Tell me, what did I do right there? Which ones did I group together? I grouped the x's, then I grouped the y's, okay? Now, let's figure out what that magic number is. Taylor, what's the magic number for the first one? What's half of 4? What's 2 squared?
4.
So 4 goes here, that means a 4 goes there. Daniel, what's the magic number here? 9. 9 goes there, and 9 goes there. So far, so good, right? So that means that this whole piece will break down to a perfect square trinomial of x plus what squared? 2. Very good. Plus the quantity y. Help me out, folks.
3.
Y minus 3 quantity squared equal. On the other side, how much is negative 12 plus 4?
1.
16.
Oh, 6.
Negative 12 plus 4. Negative 8 plus 9?
1.
Hey, now we're in business. Somebody tell me, where's the center of my circle?
A las negative 2, 3.
Negative 2, comma 3. I'm so glad that you were able to switch the signs and recognize the fact that they are opposites. What is the radius of this circle? 1. Great. Let's sketch this circle together, ladies and gentlemen. So make yourself a coordinate grid. Mine's cooler than yours. Yeah. Don't you wish you could do that? Okay. So what's the center? I have to do what to it? Okay, where's the center, everybody? Hey, stay with me here. Daniel, where's the center?
It's at negative 2, 3.
Okay, so please plot the points. Negative 2, comma 3. Center right there. Okay, now what is the radius?
1.
So you need to go up 1, to the right 1, down 1, and left 1, and then you have enough information to draw your circle. So I'm going to zoom in on that right there, okay? And then I'm going to take this down a little bit, okay? And I'm going to move this down like that. So check out, this moment of truth. What was the equation that we came up with up here? Can someone read that back to me? Oh, here it is.
X plus 2 squared plus y minus 3 squared equals y.
Okay, so if we did this correct, then the graph that should be produced should be over an image that overlays my little circle. Is that right?
Yeah.
All right, moment of truth. I'm nervous. Woohoo! Yeah! Check that out. Woo! We did it right. We are good. Questions?